Hi everyone. Welcome to another interesting video on system design. So we will be discussing today, as you can see from the screen also, an important and interesting topic of designing video streaming services like YouTube, Netflix, Amazon Prime, Hotstar, etc. So primarily we will be focusing on YouTube, and you can get an idea of how other streaming services also work. So without wasting any time, let's dive deep into this interesting topic of designing YouTube in high level. So in YouTube, primarily there are two types of users. So let's say one is the content creators or the users who upload videos, and another is the consumers who watches the videos or uses these services, YouTube services. Consumers who watch videos. So in content creators, what they can do is they can upload from any device, like they can create the video from mobile phone or edited on an web application or laptop and upload from there, or upload it from the mobile phone. So this can be uploaded from any devices. So upload from any device. So the system takes some processing time to process those videos to upload into YouTube in various formats. So we'll be looking into those details in the later part of this video. Whereas consumers, they can also watch in any device. So by any device, what do I mean? Let's say it can be a mobile or a laptop, etc., or a smart TV, something, some such kind of applications. So these are, so our system design should support these multiple devices, multiple formats to be enabled to for the content creators to upload the videos and also the consumers to watch the videos. So this is our, let's say, functional requirement. And if there is functional requirement, then it would also come with a tag along non-functional requirement. So non-functional requirement are like, let's say, our system should be highly available, right? System should be highly available. By available, we mean like the system, the videos should be at a one click, should be available to the consumers, and for that we follow eventual consistency. So why do we follow eventual consistency? It's like to ensure high availability of videos across different regions. Once the video processing is done or completed and it has been replicated, let's say, into multiple data centers or databases, so that it is nearer to the video is being served from a nearer location to the particular consumer without any slight delay in video processing. But we can consider some delay in updation of metadata, like counts or view counts for that particular video, but the video streaming should be highly available. So for that we can use eventual consistency to fulfill our requirements. So this is why along with highly available we support eventual consistency. And second thing is like there should be low latency. For high availability, low latency in video streaming. And since our application is a read heavy, so let's say suppose the ratio is read to write ratio is 100:1. So like for every 100 users watching any particular video, one user uploads is a creator basically and uploads a video to the YouTube service. So these are the functional and non-functional requirements. So now let's look into details of how uploading of video occurs and how streaming of video occurs. So we will be looking into two parts. One is video uploading and another is video streaming. So let's dive into the first part, that is the video upload. So in video upload, what we do is, let's say first step is step 1. Let's say client, that is a consumer basically, content creator basically, he or she uploads a video and that video goes to video upload service. The request goes to the video upload service, and this is done using REST API calls. Like what kind of REST API calls? Let's say upload metadata video, another, let's say upload video. This type REST API calls are being sent to the video uploading service. So what kind of metadata? So in metadata, what we have is, let's say user ID, video format, size, title, description, etc. All these are metadata of the particular video, title, description, etc. That comes along, tag along with the video whenever we upload a video. So this is how REST API call is being sent to the video upload service. And after that, let's say step 2, what we have. So user uploads video in one format, like let's say if he is uploading from an Apple device, the format is different, like let's say MP4 or AVI and MOV, multiple formats which we have in which an user upload a video to the YouTube service or the video streaming service. So we need to actually transcode those or encode those videos in multiple formats so that it is available in, or we can support multiple devices while streaming that particular video. So the current scenario is user uploads video in one format. We transcode or encode these videos in multiple formats to support multiple devices. So how is it being done? So once the request goes to the video upload service, just like we saw here, a REST API call is being done. It's being sent to a transcoder, or let's say a transcoding queue, where the jobs are queued, the videos are queued, where it will be taken one by one, moved to a transcoder, and moved to a transcoder. Let's say the jobs are being picked, they are moved to the transcoder, and eventually they are converted into multiple formats. So what does a transcoder do? Let's say it converts or encodes video to multiple formats or resolution, like let's say 144p, 480p, 720p, 1080p, etc. multiple formats or resolutions. And once this is being done, the videos are actually stored into blob storage, so binary large object storage. So you can read more in details about this blob storage. I will put a link in the description. So this basically, blob storage basically denotes like unstructured data in kind of videos or images, etc., which cannot be stored in a structured way in rows and columns. So blob storage are being used to store this kind of data. So this is a overall idea of how blob storage is. What is blob storage? So once transcoder now converts or encodes this video into multiple formats or resolution, it is being stored into blob storage, and blob storage in turn sends this video to CDN, content delivery network. So content delivery network, what it is, like I can make a short video on this. If you want, you can type in the comment if you want a short video on CDN, or in one word I will say CDN is like geographically distributed edge servers, which stores static contents like images or HTML files, JSON files, or videos, etc., which do not generally change or is not dynamic, like do not change very easily, and are being served to the particular user who is being nearby of that particular CDN. So this is an overall idea of what CDN is. So once our videos has been transcoded into multiple formats and resolutions, the original storage is blob storage, where these videos are stored. They have particular URLs, and this blob storage in turn moves the videos to the CDN. These CDNs are geographically distributed, and thus it helps to faster access the video streaming process and enabling a low latency for having the video streaming process to the particular user or the consumer who is watching that video. So, and along with that, once the video along with the video, we also had, if you remember, this video metadata. So To store the video, we use a blob storage, and to store the metadata, we use an RDBMS, relational database. So relational database, what does it store? Like I also mentioned just earlier, like let's say user ID, it stores user ID, email of the user, his name in one table. In another table, let's say it has video which is being uploaded by the particular user, and the metadata corresponding to that video, like title, description, thumbnail, and URLs, where these are stored actually in the blob storage URLs, and all these are stored in RDBMS. So now since things are stored in RDBMS, and if we consider the scenario of scaling our system, so we can shard this database, and sharding can be done for scaling. We can shard the database, and we can shard the database on the basis of, let's say, video IDs, or let's say genre, or geography, or based on the content creator. Let's say one content creator is popular in a particular geography, so we will be moving those kind of videos in that particular database which are nearer to that geography, etc. So in this way we can scale our system and shard our database. So this is an overall idea of how video uploading occurs and is handled by the video uploading service. So now let's look into the second part, which is our video streaming service. So video streaming, what happens is, like, user suppose clicks on a particular video or requests a particular video, and the request goes to the video streaming service. So video streaming service in turn now interacts with this RDBMS, which we discussed before here also in the above, this RDBMS database, relational databases, and checks whether this video is already present in the database or not, and whether this video exists, or is there any permission issue for which the user cannot see this video. All these metadata and details are being checked, and once the what we check here, let's say if I write down, so we need to check the database if video exists. Second thing we do is if any permission issue based on the user or his location, permission issue based on location or user, and if all these demands are being checked and the user is eligible to see the video, the next request is being sent to a particular CDN to deliver this content to the particular user. So like this is 1, this is 2, request is being sent to the CDN delivers the content to the particular user. If in case the video is not present in the CDN then interacts with the blob storage, which is the original storage, to bring the video, to serve the video to the particular user, and also stores the video in the CDN for further the kind of a cache thing to fasten the process of next time whenever a particular user requests a similar video. And another interesting thing is, like, there are multiple ways to upload videos. So here we discussed, like, once the video transcoding has been done, the video is being sent to the blob storage. So here, instead of directly sending the video to the particular CDNs, there are two ways in which we can achieve sending the video to the CDN. One is the pull method, another is the push method, and also another thing is adaptive bitrate. So let's now look into these three terminologies. So there are multiple ways in which we can upload videos to CDN from blob storage. So what are those? Let's look into them one by one. One is the pull method. So in pull method, what happens? So like first a particular user requests a video and checks if the video is present in the CDN or not. If video is in CDN, then the video is directly delivered to the user. Else the CDN requests the video from the blob storage. The video is being stored in the CDN, and along with that it is also being sent to the user to see the video. So this is the pull method. So in pull method, user requests a video, check if video present in CDN or not. If yes, then get the video and deliver the video to the user. If no, then request the video from original storage. So this is one of the method, that is the pull method. Another is the push method. So by now you might have guessed, like since the word push and pull are oxymoron, so in push method what we have is, once the video is being stored in the blob storage, it is immediately sent to the or distributed across CDNs to hasten the process or fasten the process of video delivery whenever a particular user clicks or requests a video. So here, once video is available in blob, it is uploaded to CDN. And another thing is, like this is how videos are being served. Now if we talk about the quality of the video or the resolution of the video which is being served to the particular user, like adaptive bitrate. So as bytes go from CDN to the user also sends feedback whether it can consume at that rate of byte rate, or do we need to lower the byte rate since it is not being supported by the particular user, bandwidth is not present to support that amount of bytes which is being transferred from CDN to the user. So depending on that data or bandwidth, we can up or down the resolution. So here what happens is, as bytes go from CDN to user, the user also sends feedback, like whether it can consume at those bytes. So depending on the feedback, depending on the data or bandwidth, depending on data or bandwidth, we can up or down the resolution. So these are the three methods in which the video is being made available to the CDN and the blob storage, and also the kind of resolution which is being sent to the particular user depending on the data or the bandwidth. So another question which might arise is, like, what will happen in case of a big event like video streaming service fails, and how to avoid those failure. So for that we scale the system. So the question is, before moving into the solution, let's see the question. You can think about it while I am writing the question. So what will happen in case of big event the streaming service fails? How to avoid failure, basically. The streaming service fails. So how to avoid this? So first we can scale the system. One of the solution is scale the system. As we have seen, we can shard the database based on various criteria to distribute the data across multiple data centers for fastening the process of video streaming with a low latency. And we can also cache the response which video streaming service gets from database in memory also. So cache the response. So what do we mean by response, and what do we have? Like, it's the metadata of videos. We can also cache static data. So like it's like video streaming service. We have the video streaming service. It serves request from the cache, thereby having a low latency and high availability and fastening the process. If anyhow this the requested service is not being present in the cache, it goes to the database. Database updates the cache, and in turn it also serves the video streaming service. So it's like this is the flow of request which is being handled in case of the requested service not being present in cache. So this is how we can avoid failure and for a big streaming event. So other purposes for which we can use our YouTube also is like analytic purpose, like to check the number of viewers, the click rate and all, etc. For analytics purpose we can use. Another is like we can have fault tolerance, like even if one of the data center is down, our video streaming service should not go down. At least the video should be made available, although it might incur some latency, but the videos should be at the end of the day available to the particular user or particular streaming service. So we can use a master slave approach for database. Since it's a data heavy system, we can optimize the storage from cost standpoint. So all these things we can also keep in mind while designing our streaming service like YouTube or Netflix. So this is all about a high level design of how we design YouTube and streaming services like Netflix and Prime, etc. So if you want, I can dive deep into the details of how transcoding works, how data is being stored in CDN, what is CDN and all those nitty-gritty of the internals which we use in designing of this streaming services. So you can write in the comment section. But this is overall a high level design of how a streaming service happens. So thank you for watching this video and stay tuned for more such interesting videos on system design.